In this slidecast, we'll talk about exceptions. There are several ways we can indicate that an error has happened. We can return a special value, we can use a Boolean return value, we can use global variables, print error messages and possibly exit, or put an input or output stream in a failed state. The first three of these options let the user of a function respond to the error. Now here's an example where we return a value from this get element of x, and as long as the value is greater than some predefined minimum, we have a valid value and we can do something with it. Otherwise we have to recover from the error, and then we can continue normal processing. So this option works maybe an if then else if there's one possible error, this array out of bounds error. Now another way to indicate an error, especially if there's several possibilities, is through the use of exceptions. So exceptions are used to signal that an error has happened, and you can insert code into your program that throws an exception when a particular kind of error occurs. And then when the exception is thrown, the normal flow of execution is interrupted, and an exception handler lets you catch or handle this exception. If there's no exception handler, then the program terminates. Now this slide shows the syntax of the throw statement. And the syntax is the keyword throw followed by an expression. And here are two examples of throw statements. We throw followed by a string, which is an error message. Here's throw followed by a reference to the out of range class, which is an exception class that's defined in the standard library. Now the normal sequence of execution is interrupted when a throw statement is encountered, and control is transferred to the nearest exception handler whose parameter types matches the type of the expression. So this first statement is of type string. So if there's an exception handler that accepts a string type, then that's the exception handler that will be executed. And this exception handler is like a function, and the rules for matching an exception handler are the same as the rules for matching overloaded functions. So in this second example, we have this out of range class, and this looks like a function specification, and it matches the constructor, one of the constructors for this out of range class. So there's the out of range class can construct an out of range exception object, and it takes a string as input. So in the second case, if we have an exception handler that takes an out of range object, then that's the exception handler that will be executed. So if there is not an exception handler in the current function, then control returns to the caller, and we see if there's an exception handler in that routine that takes that type of exception. And if not, then we return to the caller again, and control will continue to return until we get to the main function, and if there's no exception handlers found along the call stack, then the program will terminate. So here's an example of our get element of x function, and we check to see if that index value is out of range, then we throw an exception, this out of range exception. And so this expression here in the throw statement can be an object of any type. Okay, we saw the string and this out of range objects here. So there are some standard exception types defined in C++ in the standard library. And for those types of exceptions, control is passed to the exception handler if one's available. And then you can define your own exception types either by inheriting from the existing exception class hierarchy in C++, or even defining your own types. And for most of what we're going to do in this class, you can use the standard types that C++ provides, the standard exception types. Now if an exception occurs and it's not caught, then the program stops and an error message is displayed. And it's dependent on the compiler and the operating system. So G++ on Linux simply says aborted. Microsoft.NET C++ compiler gives the following error message. In order to avoid uncaught exceptions, you can write a try block that can throw an exception and follow it with a catch block that catches the exception and handles it. Now, if all the statements in the try block execute without any error, then the exception handler is skipped over. We'll skip past the catch block. Now, if this out-of-range exception is thrown, then control will come to this catch statement and will execute the body or the statements here. And the heading for this catch block is similar to a function declaration. The parameter EX has type out of range, and this ampersand means that this is treated as a reference parameter. And then EX can be referenced just like in the body of a function. EX will be treated as a parameter. Now this exception handler displays an error message and then exits with an error condition. Now this line passed to the standard error stream is the string passed to object EX when it was thrown by getElementOfX. And this what method is defined in C++'s exception class. So the exception object is actually thrown or created inside the function getElementOfX, but it's handled by the catch block in the caller of getElementOfX. Okay, that's similar to what we saw before, where functions can return values and we can do some error processing in the caller. Now you can have more than one catch block following a try block, and each catch block handles a different kind of exception, and they're checked in the order in which they appear. So this code might throw an exception, and then we have, we can have up to n catch blocks, and we'll check one by one, and the first one where the type parameter matches the type of exception that was thrown, then we'll execute the body of the catch statement, and then if we don't abort, we'll resume execution after all of the catch blocks. Now in our example, the catch block handles the exception. It basically duplicates the default behavior for uncaught exceptions, just with a little bit more informative error message. We don't always have to abort the program. Let's look at some examples. Now here are some standard exceptions defined in C++, the reason they're thrown, and what kind of operators will throw these errors. So pause and take some time to look over this list and see if you can think of instances where you could expect these kinds of exceptions. Now here's a program that demonstrates this out-of-range exception thrown by the substring function, if the start index is greater than the length of a string. So we include stdexcept so that we can have C++'s some standard exceptions from C++. And now we've got a try statement here, a try block, where we reference this substring function, and it could throw an out-of-range exception. And if it does, then we'll catch it here in our catch block, and we'll execute these statements. We'll print out an error message that the exception was thrown, and we'll include the start position. And we know that because that was passed in as the parameter, and we'll get whatever other information is included with the exception, and then we'll return a 1 from our main routine, which indicates an error occurred. And here's some sample dialogues. If you type in a string unnecessary roughness and we enter the start position of 2, then the substring is necessary roughness. But if we enter that string and say a start position of 30, which is longer than the length of the string, then we'll receive this error message. A common source of errors is user input. But instead of aborting, we might like to recover from the error and give the user another chance. So we could use the following sequence. The user can input some information I, and if the input of I was successful, then we can process it. Otherwise, if we have a problem reading I, we might want to attempt to recover from it. But we would have to test the state of cin, this input stream, after each input operation to do that. Now another approach is to have the iStream object throw an exception. So we want to have it throw a failure exception when some input error occurs. So to do this, we need to call in advance. We call the member function exceptions before we start doing input. And we pass it an error flag such that when that error, it indicates the kind of error when it occurs, then the iStream should throw this failure exception. So if we call it in advance with this cin exceptions and pass it the fail bit, then that sort of instructs the stream to throw this failure error when an error occurs. And let's see how this is used. Here we have a readInt function. And the first thing we do is we say cin.exceptions with the fail bit, and this sets up this input stream so that when an error occurs, it'll throw this failure exception. And in this readInt, we've got a while loop that just continues looping, prompting the user and getting some input. And if it reaches this return statement, if an error hasn't occurred, then it'll return this integer. Otherwise, if an error occurs with what the user types in, we'll catch that error here, inform the user that they've entered a bad string. We have to reset the error flag, and we have to ignore all the data that the user typed in so that we can go back and give the user another chance to start over. So maybe I'm asking the user for a zip code or an account number, and if they happen to type some non-numeric character, this is the way that I can flush that data and go back and give the user a second chance instead of aborting. Now, standard exception classes are listed in this table we saw a few slides ago, and they're all derived from exception, which has this member function what, and all exception classes have a constructor that takes a C-string argument, and you can retrieve the value by calling this function what, and outputting it to a log file or showing it to the user. So this failure is a class derived from exception, and the two handlers in the code below must appear in the sequence shown to avoid a warning message. This would be a warning message from the compiler. So if we try to call readInt, and now we can catch this failure error condition, or we catch just an exception. So notice we catch the very specific failure condition, and then exception is sort of the base class. That's sort of the broadest definition, and it would catch all kinds of exceptions that inherit from this base class. So this is sort of a catch-all in case some other error is thrown besides failure. So all exceptions should be derived from this exception class. There's no guarantee that that's the case. You can go ahead and create your own exception class hierarchy. So in that case, even if we had an exception handler that caught std:\exception, we might miss exceptions that were thrown based on other types. So C++ has a catch-all expression. So you can use these three dots, and that's as the exception handler parameter. And C++ doesn't provide a way to determine what exception was caught by this ... parameter, but it does let you catch them and specify an error. So here's this readInt function again. We'll catch the failure case, which might be the most common. Then we'll catch any other exception that inherits from the C++ standard exception. And then this final catch-all is here, and if we get some exception that wasn't handled by these prior two, then we'll just say undefined exception occurred in readInt and abort. And this at least, if we leave this off, we might return back to main and just abort the program. Maybe the advantage of doing this is at least we have some information that we know we failed in readInt, and that can help us streamline our debugging efforts. And that brings us to the end of this Slidecast.